Good morning, good afternoon, and good evening. In this world in which very little is live and so much is remote, we bring yet another presentation over Zoom or the interaction method of voice, actually through Bright Talk. And I'm Sandeep Uttamchandani here with me. I'm Floyd Smith, and we're here to talk about the self-service data roadmap. And I'm going to switch to slides now that Sandeep is there. We'll have a picture of him and a picture of me coming up soon. And here are our slides. I'm going to do most of the talking for the first few, and then Sandeep will take us through the actual content. And this is a conversation. Please.
Well, Floyd, I'm guessing you're having internet issues. Your voice is a little choppy.
I'm sorry, could you say that, Sandeep?
Your voice was cutting off. I know you're having some internet issues.
Okay.
Coming to that again, jump in.
Okay, yes, I was hearing some cutting off in Sandeep's as well. So I'm going to address that by speaking slowly and hoping that helps make up some of the gap. I'm connected to audio by phone, so I will cross my fingers that works. So this book by Sandeep is actually a summary of a lot of what he's run into in his career. And what he's learned is that the best way to organize your data services in an organization is to make them as self-service as possible. And the book actually takes on the big issue of having, we're getting a question. Of course, we will send you a copy of the slides afterward and access to a repeat of the presentation at any time. So yes, you will get that information. And a lot of the depth though is in what Sandeep shares about different topics. So we invite you to do all of it. You look at the slides and go through the presentation again, listen through the presentation again. And a lot of people do a presentation like this and then later share it with their group. So that's recommended as well. And that goes into what I was saying is that Sandeep presents in the book really how to take your whole organization and make a darn data thing that you do self-service. However, the nice thing is about it that it's fractal. It works at different scales. So you can use his book to plan a specific service that you want to make self-service, or in a department or a part of your organization, and that then gives you the experience and confidence to scale that up if you'd like. So you can zoom the lens in and out as needed in your organization using this book. It's also kind of restful. A lot of the work we do, we call the area that we work in data ops largely, and a lot of the work that we do is reactive. Something's broken, you got to fix it now. And then you have to learn how it works and why it works the way it does in order to fix it. But with the self-service data roadmap, you're really taking the big picture, and it's kind of relaxing and refreshing to have discussions at that level so that then when you react, you're reacting from a better place. So just a few thoughts about the book. I recommend the book itself to you, and you'll get a deep dive into part of it today. The structure of the series that we're doing is that we'll talk about that more soon. First, let Sandeep introduce himself.
Thanks, Floyd. So I'm Sandeep. Very happy to be on this webcast, and the way to sort of motivate what I've done, and in the book as well as my broad career, I've been in the data space for more than 2 decades. And if you look at all the value that data can generate in the form of AI, ML, and detailed advanced analytics, it all relies on data. So in my career, one of the biggest thing I observed over my two decades in being involved in multiple different aspects of data, all the way from building data management software to running data at scale to truly delivering business value in the form of analytics and machine learning on top of data. There were some common themes that were very, very clear in our approach across the board, not a specific organization. And there were some patterns in terms of, the data platform by itself being in this perpetual, running behind shiny new technologies, right, without really having a clear purpose, or a lot of motion, a lot of activity in the data platform level, but very little business impact. So that was really the motivation for writing this book, and very excited to be talking more about it. In addition to the book, I do blog on Medium. In fact, a lot of additional ideas and things that I continue to work through and share my experiences. So if you follow me on Medium, I think you'll, in addition to the book, definitely be getting additional insights. And I really like to share that. Share the details. But that's me in a brief nutshell.
Great, thank you, Sandeep. I'm Floyd Smith, and I'm our Director of Product Marketing. I've worked in several startups, and I'm very happy to be at Unravel Data. We're taking on a big problem, and which is making data ops work well. And we have a fun solution. So we actually enjoy talking about it. So we're always happy to talk to you about what we're doing at Unravel Data, but also about data ops more generally. We recently had a conference, Data Ops Unleashed. And if this is the first you're hearing about it, please visit our website, and you'll see an area there for dataopsunleashed.com. And I'm going to present the URL for that while Sandeep's speaking a bit later, so that you can check it out. A lot of great sessions, and some of them are vendor specific to specific solutions, and then a lot of great general discussion of data ops as well. Just looking through the list of presenters and reading the topic descriptions is actually a little education in a good part of the modern state of data ops. So I think you'll enjoy that. I'll give you the URL soon, and diving into any of the talks. We're also going to do a series of blog posts about some of the discussions. So keep an eye out for that as well. And then a bit more about the book. I started to talk about it on the first slide because I'm excited about it. But again, it works at different scales. You can use it for a project, and you can use it for a multi-billion-dollar organization, which actually Sandeep has done previously to Unravel. That's why he came to Unravel, because he thought he'd take it easy and get a break. No, I'm just kidding. He's worked hard throughout his career, but tried to be thoughtful and organized. And as he mentioned, make what he's doing work for the business, not just be a data science exercise, which he's perfectly capable of doing. But he understands that ultimately the data team doesn't get that far if it's not very clear how the business is getting value. And some of the discussions we have with our customers, we're just part of their efforts, of course, their overall effort. They're much happier when they can show the business where the money is going. Oh, sorry, I'm getting a reconnect, so I'm going to do that. Okay.
We can still hear you fine, Lloyd.
Oh, good. Thank you. Okay, very good. So as we're reconnecting here, just the people on the data team are much happier if they are able to show the business value, and they're able to show how a certain amount of money invested yields a result in the business, and that actually presents a sense of calm, and then everyone has much more grown-up and business-like discussions, and has a lot more fun as well. So please look at this book if you're new to this area. If you're just starting to think at this scale, it's a great education. If you're a practitioner, then you'll learn a lot from it. And if you're an experienced practitioner, you'll probably have some things to say about it, and Sandeep, some ideas of your own. And Sandeep is quite accessible through his blog and through things we do at our company. He also does CDO Battle Scars, which is a podcast with a series of interviews with different CDOs, and they do most of the talking, and Sandeep just guides them into interesting topics. So a range of ways to communicate with us. Also, please email us if you have an interesting problem in this area that you're looking to address. We're always looking to learn. And if you're a practitioner doing something interesting and even a bit stymied, please reach out, and we'd love to talk with you. We might even just schedule a meeting just to talk through some of the obstacles you're facing and what we know about addressing them. I have some experience in tech management, and Sandeep, of course, has a ton of experience in these specific problems. And I'm going to turn it over now to Sandeep to take us through the problems. Please type in questions, and we'll be ready to go through those at the end of the presentation. So take it away, Sandeep.
Sounds good. So folks, to ground us for this session, right? This is actually a 4-part series that we've been talking about. So today we are at part 3, right? And the way we think about any project out there, any project that goes from data to generating any kind of insights, has 4 parts to it. And there's a discover phase, then there is a data preparation phase, then it's all about building out your models, building out your dashboards, your analytics, and then finally the operationalize, which tends to be extremely exhaustive. So today we are going to focus on the build side of things. Right? Now, to set the context on how we look at, in fact, if you look at the objective of this webinar today, the objective really is how to help you better manage your data platform, right? And this is basically a problem I have struggled with over multiple experiences, multiple gigs, right? Let me start off with a very basic question, which is, how do you measure the health of your data platform? What is that one metric that you can say about your data platform? And I struggled with this question myself for several years, right? We were investing, we had multiple teams, we were deploying the best of the best available on cloud, available through vendors, available through open source. And the question always remained, how is all that effort that is put at the data level, data platform level, translate into business value? So if that's the question that resonates with you, right, that's the aspect of how you should be thinking. And when I think about this question, this is a question which is not just applicable for data platform or data engineers. It is equally applicable for data scientists and data analysts, because without knowing what happens on the other side, right, you're trying to run as fast as possible to get the insights that are required. Maybe you're building a fraud model, a forecasting model, a propensity model, whatnot. It all boils down to, under the covers, how quickly are you able to discover, prep, build in terms of the richness of the platform, and then operationalize. So I basically think this is a common topic which is applicable both for users, that is data scientists, analysts, as well as data engineers. So going back, how do you measure the health of your platform, right? How do I know whether you're truly world-class? And there is one metric that really, this book is focusing on, and that metric is time to insights. So time to insights essentially defines, or what distinguishes a good platform from a bad platform, or an immature platform from a mature platform, is time to insights. How quickly can you go from your raw data to generating the insight? And the picture that you're seeing here on the screen is now really to break that thing down. So in the book, we break down time to insights into 18 key buckets. So time to insight by itself is a summation. It's a combination of everything that you're seeing on the screen, right? How quickly can I find data? So what is the time to find? Even if I find the data set, if I'm not able to interpret, this is in the discover bucket, there's time to interpret. This is where your catalogs come in. This is where all the metadata information comes in. Once you're able to interpret, especially if you're building a model, an ML model, that's where you need to create features that are trained more in a feature store format. So hopefully you get the picture, which is time to insight is broken down into a summation of these 18 KPIs. And honestly, folks, that is the secret sauce, which is you have to focus on each and every KPI or parameter here and see what is burning in your platform, right? So, just to just to drive this point home, if you're a small startup, or a company with very little data, time to find is not going to be that difficult, in the sense that if you look at most of the Web 2.0 companies, they really have a small number of very large tables, right? Whereas if you're, a brownfield company being in the business for 15, 20, 30 years, time to find it becomes a very, very critical thing for you. So using this scorecard, you really have to figure out where you need to invest. Today, I'm going to talk about the build aspects, right? And when it comes to build, I've basically focused on 5 key things which are very important for all of you to get a handle on in your platforms. So the first one I refer to as time to virtualize. And this is all about how do you support querying across multiple systems. Today we are polyglot. We are all adopting polyglot persistence, specialized query engines, specialized frameworks. There's no one size fits all. So, it's one thing to have a very fancy combination of systems. It's the other thing to then really use the data sitting in, key value stores, document databases, sitting in the lake, mapping it all together. So we'll talk a little bit more about the first one, time to virtualize. A lot of organizations struggle there. Time to transform is a very important part of the build process. This is how to get your ETLs standardized, how to build robust ETLs, what all is required. Because, and when I say ETL, it could be ETL or ELT, doesn't really matter. But the key tenets there, a lot of times you get tripped by not having the ability to write robust transformations. And this is where, again, the skills of the team vary. There's these UI-centric ETL or transformation tools to the other extreme, where you can write your own Spark big data programs or Presto programs to do the same. So that's the other dimension, which is very critical to get a handle on. Time to train is specifically in the context of machine learning models. In fact, a big chunk of time in launching machine learning in the build phase is all about training, right? And training is an extremely iterative process, and clearly it's a topic just by itself. Time to integrate is all about continuous integration for your systems. Pipelines are not static. In fact, one place that I have seen several organizations trip is that they may have a pipeline, they may build it out, get rolling, but then the business need has changed, or a business metric or a business definition has changed. And to incorporate that change back in production is really slow. In fact, it's slow that it really impacts the business. So time to integrate is focusing all about how to build continuous integration of your data pipelines and machine learning models, because changes are inevitable. Changes are continuous. Changes are just the way businesses work. And the last thing in the build phase, which may or may not be applicable broadly, is the whole aspect of A/B testing or experimentation. Oftentimes, even with models, there are more than one models that are built out, which and you honestly don't know from a business standpoint, is it better to have a prediction with a specific value shown in this form or something else, right? And those are the kinds of things which need to be again automated, because you may have everything, you may build it out, but guess what? If you are not able to experiment, and again, not every business is there. If you're a Web 2.0 company or anything in the SaaS space, experimentation is absolutely critical. If you have a software as a service. Um, so that's the context, folks, about the aspects of build, which from a broader standpoint, hopefully now you understand you have to think of your platform holistically. Focus on, if I basically were to ask, what's that one metric that you care about your data platform? That metric is time to insights, right? And the way I have done this in the past is for various projects, be it building a dashboard, revamping existing dashboard, building a machine learning model, really calculated that in the projects, right? Figured out how much time it took from the idea to actually getting this out in production. And once you have that math, you really then break it down as to where was the time spent, where exactly. And this kind of a thing can also be done as surveys. In fact, there's some great input that comes from the users, data scientists, data analysts, marketers that are using your data can actually point it out. What are the aspects which they are getting slowed down the most? And then again, picking one or two of these boxes every quarter or every 6 months and going all out, really making it, go from red, that is being the slowest part, to building the automation. And there are tools out there. You don't have to start from scratch. Across the board, there are tools that exist, especially if you think about Unravel. Unravel plays heavily in the combination of operationalize, which is really where we simplify quite a few of those when we talk about this, but also during the build phase, which is several places during the initial iterations. By using Unravel, you're able to quickly zero down, are the queries, going to be scalable? Are there going to be errors that exist, which will trouble you during the production phase? Things that you can be proactively thinking from the software lifecycle management. But more of that in part 4. For today, I'm going to now pick the first block, which is the virtualize block, and talk a little bit more in that context. Okay, so kind of laid out the 4 blocks there, the pieces there. And when you think of virtualization, this is how we need to be thinking about what is involved. What does virtualization mean, right? And some of you may not be familiar with the term, but you'll be familiar with what its implications are, right? So similar to CPU virtualization, right? When you think about how VMware, for instance, created or transformed the way we consume physical CPUs into representing them as virtual machines, right? Now, in a similar way, one thing that's very, very clear is that data today has multiple, I would say, multiple different systems where data resides, right? So even when you talk about a data lake, sometimes folks think of data lake as unstructured objects, right? That's not the right way to think about a lake. A lake is basically a central repository. And in the repository, you could be using multiple systems. This is where polyglot, if some of you are familiar with that term, polyglot basically is a programming term which was used in polyglot programming languages, but also polyglot data systems, basically meaning that there is no single data model. It's not that I have to store everything in a relational form, which is what we did 20 years back. At the same time, it is not that I have to store everything as a blob, right? It is really a combination of the how do you represent or build the right data model? So if it's a key value store, you'll have, things like Cassandra or, other key value systems that are out there. If you're looking about document databases, MongoDB and equivalent scenarios out there, graph represented differently, time series represented differently. So all that data lives together. And during the build part, your question really is a couple of things. First, if you have multiple environments, which we do, right? Environments in the form of, you can think about multiple different clusters, or most organizations. Um, uh, yeah, I think there's some background noise. Maybe Floyd, you can go on mute probably. Okay. So in terms of multiple different, like typically in many organizations, we create, or you would have multiple clusters created for with different properties. So let's take an example, right? And the very first one, picking the right query execution environment. As you configure your big data cluster, you may configure clusters with different properties, clusters which have more memory, clusters which have more compute, clusters which are faster, clusters which are potentially, applicable for, analyzing large blocks of data, but not really, not really on the critical path in terms of executing fast. They are scheduled jobs that just need to run in the background. The key point happens is that most organizations have multiple of such clusters, and the number one thing in the build process as we are building and getting these queries to run is, what environment should I pick, right? And this is not just at the time of building, but eventually as you're even trying to deploy and run this, you need to be clear on what is the right cluster configuration for running my job. So one key part of virtualization is automatic query routing, right? And this is where, if some of you are familiar with the Netflix Genie project, that's an example, just to give you an idea there. The second part of virtualization is focused on, now that you have multiple systems, you have multiple big data, NoSQL stores, all the way from key value to graph to document to sitting in the lake. How do you query that data? How do you essentially write queries such that you pull the data from from different systems, and like are able to combine them? So that's what the query language pattern is, and I'll briefly touch on all of them. And the last one really is the federated query pattern, which is the ability to combine results, join results, when data is actually sitting across different stores. So when you think of data virtualization and automating, these are three key building blocks to automate: picking the right environment, formulating data store specific queries or polyglot specific queries, and the last one is joining data across multiple sources. So very briefly, I'm going to touch on each of them. And again, given the limited time, it would be clear that we'll not be able to get into all the details, but love to take on questions, and also there's a lot more details covered in the book, as well as I'm available for chatting. So when you think about data virtualization the query routing, right? This is the classic example where, as the jobs are submitted, right, and some places, in fact many places, have different ways. I really like Netflix Genie as a very good example. In fact, we have built homegrown versions of this as well. But the idea tends to be that as the users submit their job, ideally they should not have to worry about anything in terms of which cluster to go for. Should I be running this on Hadoop? Should I be running this on Presto? Should I be running it on specific configurations to specific configurations that are relevant within a cluster which has a lot more memory versus a cluster which has a lot more storage. So this is where, instead of data analysts and users creating a Jira ticket saying, I need to run my job, right? Please schedule my job. The whole idea of making it self-service would be having automation where you submit a job and the service itself figures out based on the cluster criteria and the type of job that you're submitting, and it picks the best cluster, right? And this is a kind of service which really pays out in the long run. Oftentimes, there's just a lot of to and fro that happens when it comes to users asking to run a query, then specifying what they're looking for, specifying the properties. So I would really recommend, as you think about automation or self-service, especially for the first block of data virtualization, having a service which does automatic cluster routing is something to really look deeply into, right? Now, moving on, the second part that I mentioned as a part of virtualization is how do you query different systems, right? And made it very clear that clearly there is no silver bullet, right? There is no single form that data can reside in, and the reason for that is, data has three flavors to it, right? Structured, unstructured, and semi-structured. Now, for structured, there's a relational world. For semi-structured, this is where we've kind of, as a community over the last 15 to 20 years, really innovated on different data models, right? Which is where the whole NoSQL movement kind of came in. And for completely unstructured, this is where you would have data stored in the lake in some form and really analyze that. Now, while this is good, it optimizes it. The big question a user may have or an app has to figure out is, okay, how do I query them? So a Cassandra call, which is a key value store, is going to look different from MongoDB. And again, it's not just the query, the syntax of the query, it's also the semantics. The transactional properties tend to be different across these systems. And in this category, obviously, depending upon the skills of your team, if your team is deeply familiar and you have experts, you need to create a layer, which is what I refer to as the query level virtualization, right? And there's an interesting example over here, which is languages such as PartQL, which is again, this is an open source version. There are many different variants of it. This is just one example, which I've seen some very interesting studies, and we've applied this a bit, right? Is the ability to where you write a query and the query gets translated into the right system. So more of a database agnostic version. So again, if this is an area where you have a lot of polyglot persistence, and if you are getting bombarded by users not either using the syntax correctly or just creating Jira tickets for the data, or writing queries poorly, and then a lot of time being spent just to clean up and get things correctly implemented. This is the second part within the virtualization which needs to be automated. Automated in terms of really making sure you can streamline these operations. I'll wrap up with the third piece, which is more along the lines of, and I'll just bring this slide up, is more the federated query pattern, right? Which is, if you look at modern query engines, right? So in traditionally, we used to have query engines that were deeply coupled with storage. So if you bought, let's say, a database solution, the database solution is both a query engine as well as the data that it persists in a specific format, right? Today, things have been decoupled. So query engines such as Spark, just to take an example, can actually go and query data across multiple different systems, multiple different formats. It can pull data from key value stores, pull data, read data in Parquet format, pretty much anything that you can think of. The query engines are able to support and represent, so that you can be writing a query and joining data which actually lives across different systems, right? And as long as you're able to specify that, the federated query approach would be pick a query engine that can live across the different data stores that you want to support, and really go down that path. So that, in a nutshell, folks, essentially is what I wanted to really summarize. And if I were to again build context back here, build today tends to get slowed down across various categories. Now, there is no single answer in terms of what your pain point would be, because, to be honest, these pain points vary based on um, the process, people, technology. That's the combination, right? And the way to think about this is, depending on what you're trying to accomplish, depending upon what processes you already have, depending upon the kind of people on the team, these pain points vary. It's like, these blocks will be red, in different organizations in terms of being a bottleneck, whereas green in some different organizations. So with that context, really think about first what is right for you. Get a proper landscape of what is slowing you down with the focus on time to insights. And then when you get into the build phase, you further break down build. Today I talked about virtualize, and virtualize itself basically has three key patterns. Like, the query routing pattern, that is routing queries to the right clusters. Most organizations have multiple forms of clusters in production and dev with different configurations. So how can a user run their job on the right cluster? This is a perpetually difficult problem to answer, because clusters come and go, clusters configurations change, users have no clue what they need. So query routing is one very important piece in virtualization. Second piece really is how you deal with polyglot. If you're using multiple systems, looking at languages like Particle, and there are other examples out there. And the third piece in virtualize is really about if you're using decoupled query engines, which most of you are. These query engines do support multiple forms of data stores. They can pull the data, join the data, create a view of basically a single abstraction. So irrespective of where data resides in its form of structured, unstructured, and relational, maybe you to pull that data. So again, most organizations may pretty much have standardized, let's say, on one system, in which case, some of the aspects of polyglot may not really be applicable in your world. So at this point, I let me look if there are specific things to bring up, or specific questions here. Floyd, basically, should I hand it back to you, and maybe we can continue in terms of talking about the next slide?
Yes, let me do that. Thank you. And the data ops infinity loop is actually a structure that started with Gartner, describing what data ops is. They popularized the term and put it on their hype cycle a few years ago, and it's been moving up the hype cycle ever since. We've actually added a couple of segments to it to try to capture the totality of what goes on in data ops. And this is basically a perpetual motion machine version of the project-based approach that Sandeep was just describing. So if you start in the upper left, the first thing you do is plan. When you have a need and you're aware of it, you create a plan, and then you go and create. That's the development phase, which includes machine learning and AI, as well as traditional algorithmic software development. You orchestrate all the pieces, make sure that they work together, and you bring it live internally and see if it actually does anything. Then you test and fix that. Then you have a continuous integration process where first time you're integrating for the first time, then in the future you're integrating new capabilities into it. So that's when in DevOps, that left side is the dev area, and in data ops, that's the area that data science tends to focus on, is getting you to a deliverable. And then ops tends to predominate once things go live. So you're deploying, you're operating, you're running it, you're monitoring what's going on, and you're optimizing what you're seeing there. Now, of course, a problem can get fixed in the development phase, or it can get fixed live. And you can be getting developers involved in live code, of course, trying to fix things. That's where the back and forth goes on. And the reason to have this as a loop is so that everyone's aware that they're always responsible for the thing working, and as Sandeep puts it, delivering business value, whatever stage of the life cycle you're at for that software. You gather feedback, and then you sit down and plan again. You make bigger changes. And we've been describing this as kind of a double loop round table. So if you bring all of the players together, you know, the original round table was a bunch of tough people with sharp swords, right? But you sit them down at a round table, you get them talking, and instead of fighting each other, they actually hammer out solutions in discussion rather than in fighting. So that's the DataOps Infinity Loop. And when you get the slides, there's a link actually here to the conference, blog post about it, and a lot of videos on YouTube. I didn't mention that, but we have videos all over the place on YouTube. So again, this is the live and operational version of the project-based approach that Sandeep is discussing. And then we here at Unravel Data talk about simplifying data ops, making everything easier. And part of what we're discussing here is bringing AI into production in a sustainable way. And we actually use AI within our product to help make the job of live ops, especially in particular, easier. But there's a really nice feedback you'll see when we talk to some of our customers, which we have as case studies online. There's some really nice feedback back to the planning and development phases when people learn what their problems are, and we can talk a lot more about that. So that is the end of the slides. I'm going to go back to the presenter's view. Yes.
Yeah, Floyd, just go back to the infinity loop, right? There's definitely one aspect I wanted to highlight here, is that when you think about this loop, right? When we think about this is basically how software development is done, right? And the same is applicable in the context of data ops or data pipelines discussion that we've been having. One way to think about this loop, right, is during every phase or every stage of this loop, right? As a data or applying the concepts of data platform, there are interesting examples and something that we've actually seen and working across customers in production is how do you build checkpoints, right? How do you verify that through these stages? So specifically going back to the earlier breakdown where we're talking about build, and we then the last phase is the operationalize phase, right? This is all combined in this loop. And if I would take one example, while going from this loop of continuous integration, if you look in this picture, when you're going from continuous integration to deploy, as shown in the picture, now that's one example where how do you verify that the query that you're about to deploy in production will not bring down your system, or will not contend the resources, will not slow down existing business critical SLA based apps that are running, right? And these are the examples where today you have two options. Option one is to have gatekeeping, right? Gatekeeping in terms of for every promotion that happens in production, there's some team that manually verifies, makes some checks before they promote it, right? Extremely slow, not scalable. But that's one route. Other route is free form, let it go, and in production, taking it on. And like some folks like to say, hope is not a strategy. So that falls in that bucket of using hope as a strategy. But the third form is really about how do you automate those aspects. Again, going back to the broader theme of how do you make these self-service, right? And a concrete example within this context, for instance, is we have several customers that use Unravel because Unravel focuses on applying intelligence and analyzing jobs, analyzing the status in terms of how the data for this job is laid out, how the query is written, how the job is configured, to essentially provide, think of it as a score or a recommendation, right? And that is a very good indication, which actually can be self-service to the end users and places that we've worked with. Those customers have a clear process which says that, unless these recommendations are addressed, and as long as your query, your job is not being flagged by Unravel as requiring optimization or potentially rogue, the thing can get promoted into production. So just wanted to highlight, going back and tying some of the concepts together with reality. And these checkpoints, obviously, I just mentioned the deploy example, right? Pretty much at every intersection, you can essentially be thinking of how to make those intersections self-service checkpoints, right? We can think of it as, okay, when you're going from plan to create, typically in the planning phase, it's all about, okay, do we have the resources, right? Is there a checkpoint? Oftentimes, more and more workloads get added. I've seen this firsthand. And again, hope as a strategy. You wait for something to break or hope that it doesn't break. But that can be systematized, again, by using forecasting, analysis of the existing schedule. And there are multiple tools out there. And Unravel definitely is something that I would recommend, which is a lot of focus and intelligence built in. But there are open source variants that one can stitch together depending upon the appetite, and so on. So when you go from create to orchestrate, again, there are clear aspects. Orchestrate to test and fix. One of the biggest things I've seen in test and fix is really optimizations, like, especially when you're trying out with toy data, with a sample of 1,000 rows versus deploying it then in production where that query is not running on 1,000 rows, it's running on a table with 1 billion rows. Lots of interesting things are going to happen, right? So that automated analysis that can upfront flag out some of these become extremely critical. So I just wanted to take a moment and kind of tie this back and how critical and savior or a time. It's not just efficiency and improvements. It's really about data being critical to the business and making sure that you kind of apply the same rigor to data. In fact, I like to refer to as data as code. The same rigor and practices that we apply to code should be applied to data pipelines, data apps in our journey.
Yes, and I'm going to end the slides now and put us back on live presentation for some Q&A. And I just wanted to mention that the jobs that we're talking about doing here, the roles that we just showed around the infinity loop, data scientist, data engineer, data operations, they're tough jobs. And so here we are introducing all these abstractions during this discussion, right? Sandeep has his 4 silos with multiple steps in each silo for solving problems, and we're talking about the infinity loop. But actually, dealing with things at the abstraction level really helps conversation. For instance, in the infinity loop, somebody might say, well, the problem is that we're using the wrong file format. And someone else will say, well, the problem is that users are constructing their queries wrong. And so the infinity loop really helps with that, because you can say, okay, well, the choice of file format happens in the plan phase in the upper left. And getting their users to do better querying is something you can handle, at least on an ad hoc basis, during operations. So both people might be right. They might each be right that that's the #1 problem. It's just that it's different parts of the cycle where you can address those issues. I had a specific question for Sandeep that came up in an earlier discussion. You mentioned on a very large project that you did, Sandeep, that you had not chosen to use Parquet files. I think you continued to use CSV files on the move to cloud. when was that choice made? Why was it a problem? And why couldn't it easily be reversed?
Yeah, that's a great question, Floyd. So typically, some of the data, and again, some of these choices are historic choices, especially if you've been collecting data for years and years together. Uh, Converting data formats essentially today is problematic because the way queries and apps are written, essentially they rely on the actual specifics of the data, the schemas of the data. And in fact, there's a very interesting work out of LinkedIn with a project called the DALI project, DALI, where they were really focusing on something similar, like a very similar exercise. How do you transform data formats without breaking any queries, without having impacting? Because, okay, the moment the format has changed, the moment the schema structure is changed, you will have to go and rewrite, which is a huge shift in large organizations. So within this context, again, going back, some of these choices, I would basically say doing it correctly. And the way to think about this is whenever you have a choice, doing that due diligence in terms of, okay, what kind of queries am I going to run? What is the right level of abstraction, right? What kind of, I would say, data layers that you need to build, because your physical, or think of it as layer zero abstraction, may not be the standardized version you want to expose out at layer 2 or layer 3 or layer 4. What users should be looking at is more of the standardized, or what I like to refer to as standardized matrix, standardized KPIs, how those are then mapped back, going with the physical raw schema. Those are again things which the data team can actually manage. And when that happens, essentially it becomes very easy, because then when you make these changes, at least you know that the users are not ever going to get impacted. They are operating on an abstraction. What you do need to change is the schema and your ETLs that you've written to go from the raw schema to the standardized matrix. So planning is key, including thinking of abstractions. I think that was a key lesson learned through the exercise.
So that brings up a different question too. Some of the best books on these topics are basically consultancy in a book. And I think of your book as being an example of that. Many things that a consultant would say, actually, they often don't explain the context in which they're operating. They just tell you, do this, don't do that. And you often don't really get the bigger picture unless you work with them closely. So for these larger projects, medium-sized and truly large projects, how do you recommend using consultants and system integrators, and what should you do yourself?
Great question. And again, to bubble it up, end of the day, it's all about business agility, delivering value to the business faster. And the way I look at it essentially is, once you have that goal that, okay, this project has to be delivered in a finite amount of time, then working backwards in terms of, okay, what resources do you have internally, or what are the tasks that need to be done, and correspondingly, what resources are available internally versus getting the right help and support in the form of SIs and consultants. So because typically if you start the other way around, if you simply say, let me grab in folks, at that point in time, obviously you may not be making the right choices. So going top down, business agility, deliver in 3 months, that translates to these 20 tasks that need to get done. We only have 3 people, so we need additional augmentation. And at that point, then really breaking down into what are the tasks which are, I would say, more commodity tasks, that is not really requiring the business context. Every time when you think about, activities, they fall in buckets of, okay, like let's say move data from X to Y, or convert the specific format, or whatever the case might be, depending upon what the project is. So really kind of creating a sheet of saying, for every task, how much business context is required, and really using that as a metric, especially during compliance, like, when you're thinking about GDPR and so on. Initial heavy lifting is a combination of business context and grunt work. So that is a way to approach this. And depending on if you have it all, obviously, or if you can really get system integrators which have worked in a similar domain from a business context standpoint, some of the business related relevant tasks, in fact, it is advisable to have them drive some of that, because they may have more insight and experience working with other customers. So that's how I look at it. Mileage definitely varies.
Yes, I have a couple of thoughts on to add to that. One is that it can often be valuable to have a consultant or an SI involved in a relatively limited role, just as an external voice to check in with. So it doesn't have to be a big contract, and you can do most of the work yourself. But having someone to check things with, like Sandeep might say, well, my hair turned gray because my hair started turning gray because I didn't take an extra 2 weeks and put the data in Parquet files in a big project, and we continued suffering with that for years. I might say, I lost my back at the end of the project when people were unhappy and we didn't understand their needs up front. So I do recommend
so it looks like your voice is complete. Floyd, we're not able to. So it looks like we are. Okay. We've Floyd. So folks, to wrap up the conversation. Floyd, can you hear us? Yeah. So let's go ahead. Looks like I hear some. But hopefully you found in this webinar. Just to bring up the in. Rating. Love to hear. We can, happy to follow up.
Okay, thank you, everybody.
Thanks, everyone. See you, Floyd. Bye-bye.
Cheers. Bye-bye.